In this video, we want to show by some examples that the Clairaut's theorem is valid for these functions. So the question is this: verify that the conclusion of Clairaut's theorem holds for the following functions. But what was Clairaut's theorem? Let me remind you. The Clairaut's theorem states that the order of taking partial derivative of a function doesn't matter. For example, if you have a function u like this, if we take derivative with respect to x and then with respect to y, it's equal to take derivative first with respect to y, then with respect to x. So the order of differentiation doesn't matter. The answers are the same. And we want to verify these. We want to verify this conclusion only for these examples. Attention, this is not a proof of the Clairaut's theorem. Just we want to verify that the Clairaut's theorem works for these particular functions. The first function is u equals x to the 2y to the 3 plus 2y to the 5. We start with this part. So we want to find ux, partial derivative of u with respect to x. This is a relatively simple example. What is the derivative of this part with respect to x? The derivative of x to the 2 is 2x and y to the 3 is a constant. And the derivative of this part, because it does have no x, so the derivative of that is 0. So ux, partial derivative with respect to x, is 2xy to the 3. Now we take the derivative of this with respect to y. Derivative of 2xy to the 3 with respect to y is, we have to keep the 2x and we have to take the derivative of y to the 3. Attention, now we want to find derivative with respect to y. So our variable is y and 2x is the constant. The derivative of y to the 3 is 3y to the 2. Multiply these two by each other, the answer is 6xy to the 2. Now let's start the other part. Partial derivative of u with respect to y is, what is the derivative of this with respect to y? Now x to the 2 is a constant, derivative of y to the 3 is 3y to the 2, and derivative of 2y to the 5 is 10y to the 4. Now we have to take the derivative of uy, partial derivative with respect to y, with respect to x. So take the derivative of all of this with respect to x. And the derivative of that with respect to x simply is, the derivative of 3x to the 2 is 6x times y to the 2, 6xy to the 2. And the derivative of this with respect to x is 0. So as you can see, partial derivative with respect to x then y is equal to partial derivative with respect to y then x. And this means that we have verified that uxy equals uyx. Let's see the next example. For this function also, we want to verify the Clairaut's conclusion. U is given ln of x plus y. First, we start by finding ux, partial derivative of u with respect to x. Let me remind you, the derivative of ln is 1 over the expression that is here. And also, of course, we have to multiply by the derivative of the inside. So derivative of ln of x plus y is 1 over x plus y times by derivative of the inside. Derivative of inside, in the inside we have x and y. Derivative of inside with respect to x, and derivative of x is 1. So times by 1 plus 0, because the derivative of y is 0. So derivative of inside with respect to x is just 1. And we don't need to multiply it by 1. So partial derivative of this function with respect to x is 1 over x plus y. Now from this, we have to take derivative again, now with respect to y, because we want to find uxy. The mixed partial derivative, uxy. For finding the derivative of 1 over x plus y, you have to remember the quotient rule. Let me remind you quotient rule. U over v prime is u prime v minus u v prime over v to the 2. This was the formula. U prime means derivative of numerator. Derivative of numerator is 0. 0 times the bottom is 0. So then we have minus, so 0 minus u, which is the top, but the top is just 1, times by v prime. What is derivative of the denominator? Derivative of denominator, the derivative of x plus y with respect to y is 1 all over the denominator to the 2. So this is mixed partial derivative x then y. So we have uxy and it equals to -1 over x plus y to the 2. In a similar way, you can find uy and then ux. Uy would be derivative of ln, again 1 over x plus y, times by derivative of inside. Derivative of inside again is 1 because derivative of x with respect to y is 0 and derivative of y is 1, so this is the uy. Then from this, if you are going to find the derivative of this fraction with respect to x, similar to the previous part, derivative of the top is 0 times bottom minus right the numerator times by derivative of the bottom with respect to x, 1 over x plus y to the 2, and the answer is -1 over x plus y to the 2. As you can see here, these two are equal, so this confirms that uxy is equal to uyx. For which functions this conclusion is valid? For functions that uxy and uyx are continuous, basically 99% of the functions, this conclusion, which is Clairaut's theorem, is valid. Now look at this example. U is given e to the xy times cosine y, and we want to verify the conclusion of Clairaut's theorem for this function. First, we start with ux. For finding the derivative of this function with respect to x, we have a multiplication between e to the xy and cosine y. But attention, this is a constant for us because our focus is on x. So this is only part of the function that we have to take derivative with respect to x. Let me remind you that derivative of e to the x or e to the any expression is same expression. E to the x is e to the x. E to the sine of x is e to the sine of x times by derivative of the exponent, whatever is here, derivative of the exponent. This was the formula that we remember from calculus 1. So derivative of e to the xy with respect to x is e to the xy times by derivative of the exponent. What is the derivative of xy with respect to x? It's only y, because the derivative of x is 1, and times by y because y is a constant. Like the derivative of 4x is just 4. And don't forget to multiply it by cosine y, which here is like a coefficient for e to the xy. We have to keep it. Now from this we have to find uxy. So we have to take the derivative of all of this with respect to y. Not this part and this part and this part. All of them have y. So we use product rule. Based on the product rule, first we are going to find the derivative of this with respect to y. Attention. With respect to y, the derivative of that would be e to the xy times x. Derivative of e to the xy is e to the xy times by derivative of the exponent with respect to y. Derivative of xy with respect to y is x. And don't forget to multiply this by the other parts that we have here. Plus, now we keep these two and just we can take derivative of the middle term. Derivative of y is 1, so then we have e to the xy times by 1 times by cosine y. And finally, we rewrite the first two terms and just we take derivative of this. And derivative of cosine y is negative sine y. Now we have to do the calculation for uy and then uyx. Derivative of this function with respect to y is derivative of this e to the xy times x. Don't forget to multiply by cosine y plus, now keep this here, multiply by derivative of cosine, which is negative sine. From this expression, now we have to take derivative of this with respect to x, because this is uy, now is the time to take derivative of uy with respect to x. For this part, attention, this term and this term have x, but this is a constant. So again we use product rule, but only these two terms have x, and this is always a constant, and we keep it in all the answers. Derivative of e to the xy with respect to x is e to the xy times y, and so this derivative of this is all of this times all of this by x cosine y, x cosine y. Now write e to the xy times by derivative of x, which is 1, times by cosine y, and at the end is the time to take derivative of this. Derivative of e to the xy with respect to x is e to the xy times y times by a negative sign y. Derivative of this with respect to x is this, and this is only a constant, and we keep it here. Now compare these two answers. If we add attention, this term is equal to this term. I know x and y, the order is changed, but x times y is the same as y times x. This term here is exactly the same as this term. And finally, this term is equal to this. So this confirms that uxy is equal to uyx. If you like this video, please subscribe in my channel, and see you in the next videos.